We are gotomath.com. Click on the calculus, go to area. And we are down here at 4.1, I do believe, so we can click on that. Or you could have just clicked on the button. Find the area bounded by the curve and the x-axis and the interval between 0 and 9. So we have set up our integral. However, if we're finding area, now remember we got to do special things when we find the area, okay? Even though the integral's set up, we gotta, if it's indicating area, then we gotta do special things. Now in this particular one here, we got an absolute value function. So we're gonna end up breaking this up into two separate integrals. And one of them, we're going to be looking between 0, we're going to be looking at this line right here as one of the functions, and then this line right here as the other. Okay, so in other words, we're going to be taking the integral between 0 and at what looks like 3 here. Okay, we'll be finding the area under this part of the line, and then we'll be finding the area under this part, and that looks like from 3 to 9. Alright, so let's write that down. So this can be kind of tricky here. Now I'm going to tell you the next problem, 4.2 is actually, it looks like the same problem, but it's not. Alright, and dx. Okay, so we got that written down. Got it written down, alright. So we'll go over to the whiteboard, write down the original problem. We're going from 0 to 9, and we got the negative absolute value of x minus 3 and then plus 6. Alright, dx. So we could just put all of this here in parentheses. Alright, so let's go over here and draw out what we had. So when we plug 0 in for x, we're looking at the y-intercept here. We get 3 minus 3 plus 6. We get positive 3. We'll say this is 3 here also. It's like going up and then it's coming back down again. So and we'll say that's 9 right there. So this part is what we're going to try to find first, okay? And we need to find, of course this goes on down like this. So if f of x is equal to negative absolute value of x minus 3 plus 6, okay, just making sure on something there, then we can break this up actually to a piecewise function. Alright, so we end up dropping the absolute value signs right here. Now the 6 is we're not gonna worry about 6, but we end up dropping the absolute value signs and we'll end up with a negative x and distributing this minus across plus 3, right? And then you have the plus 6 over here. Okay, so we end up with negative x plus 9. Now this is a part of the f of x, and you notice this has negative slope and it crosses at 9 up here. We'll say this is 9 right here. Okay, so it turns out that this line right here is represented by this part. Okay, so the domain is x is going to be greater than, it doesn't matter, it could be x is greater than 3. Okay, so this is good for, this is one part of this absolute value function, and then the other one is when you actually take a negative and multiply it by the negative, right? Okay, take the negative, multiply it by the negative, and so that negative ends up going away. So we drop the absolute value signs and we end up with x plus 3 right here. X plus 3. Of course, this is supposed to be 3 right here. Okay, and this, so this is not to scale, but that would be negative 3. Anyway, so as you can see here, f of x, and this domain would be x for all x less than, and we're going to have to say equal to 3, right? All x values less than or equal to 3. Now it doesn't matter if you could put greater than or equal to here, but you have to put less than here. Okay, it doesn't matter. Okay, so here's this one right here is for this line right here, right? And then this guy here is going to be for this line right here. All right. So the key is you drop the absolute value signs and you just distribute that negative across. That ends up for this line, and then you multiply by negative on the outside, and of course negative times a negative is positive. Then drop the absolute value signs and simplify. Okay, so there we go. So on this particular one here, we're going to be going from 0 to 3, from 0 to 3, and that's going to be this part of the absolute value and of our original function here, I should say. So this is x plus 3 dx. Right, so we're finding this area. So we go ahead, take the integral. We got x squared over 2 plus 3x from 0 to 3. All right, and you know what? Let's just continue this down here. So we take the 3, we plug it in. We got 3 squared is 9, so we end up with 9 halves. We might as well go ahead and do that. Plus, and then plug 3 in here. You got 3 times 3 is 9. Minus, then when we plug 0 in, you get 0, 0, so we end up with 0 there, right? And what did they say about, okay, I think this, okay, so this is exact value. We don't mention anything about rounding in here. All right, so we got 2 times 9 is 18, 27 over 2, is that right? 2 times 9 is 18, 27 over 2, yeah. Okay, so this ends up becoming 27 over 2. Now remember that's square units. And now we're going to go from 3 to 9. And this time we're going to be looking at this one here. All right. So we got negative x plus 9 dx. So we end up with negative x squared over 2 plus 9x from 3 to 9. All right. We'll go ahead and plug our stuff in now. So we'll go ahead and plug the 9 in. We get minus 81 over 2 plus, and then 9 times 9 is 81. Minus, always put a start of parentheses. Plugging in our 3, we get negative 9 halves plus 9. And you know what? Hold everything. Let's go ahead. Plug 9 or plug 3 in. 9 times 3 is 27. We'll go ahead and do that part there. Okay. So want to go ahead and plug that in. Well, you're not going to believe this, but I end up getting, I guess I can write it right here, 18. So this area here, I end up getting 18 square units, And then for this area, we got 27 over 2. So what we'll want to do now is combine, right? Add both these areas together, so we end up with 27 over 2 plus 18. I guess I'll just write it right there. 27 over 2 plus 18, and I get 63 over 2 for the total area. 63 over 2. So that's going to be this both combined area here. And of course, we come back to the page, make sure everything's good, and that's what I get is 63 over 2. Okay. All right. So converting that into the piecewise function and breaking it up and identifying, right? Identifying which line goes with which one of these guys, that's obviously the important part. All right. So anyway, we're here at gotomath.com. You can come on by, practice that, and maybe you'll see